Good evening and thank you for joining me. So this is Hurricane Erika. Right here, that's Hurricane Erika. Category 2 hurricane right now. Let's find some information on Erika. It's a Category 2 right now. Borderline Category 1, Category 2 right now. Yep, so it's a borderline Category 1 right now. So it's about to be Category 2. That's at 3 a.m. GMT, which is 11 a.m. 11 p.m. I mean. And this is Geo's Alaska. Very tight ring of convection right over here, so it's very quickly intensifying. And there is another tropical system, it looks like. That is, there we go, Hurricane Erika, 130 miles an hour. My bad, Hurricane Erika. So that's Hurricane Flossie. So Flossie, oh my, it looks like Hawaii's gonna get slammed. Hurricane Erika is Eric. So it's Eric, not Erika. So it's Hurricane Eric. So this is Flossie right here. I was right, it is a pretty substantial hurricane. That's Hurricane Flossie. Doesn't even look like a hurricane, to be honest with you. Well, that is Major Hurricane Eric right here. Major Hurricane Eric with 130 mile per hour sustained winds. So it's a Category 4. It doesn't look like it's a Cat 4, but it is. It has a very, very tiny eye. There we go. This is the one you want to look at. This is the one. Perfect. And it does have an eye. These are two mighty systems. Look at that. But even here in the Atlantic, let me reset this right now because that's from yesterday. And this is from today. And we have some stuff to talk about in the Atlantic too, but right now let's talk about Eric. Eric is going to pass south of Hawaii, thankfully. That's the good news. However, Flossie, oh no, Flossie may actually hit Hawaii. Let's look at the models right now for Hurricane Flossie. First of all, let's look at the ensemble run with Flossie. This is Hurricane Flossie, which is right now is a Category 1. So it's not a major hurricane right now. It's still a weak hurricane. So yeah, I confused Flossie and Eric there for a moment. So there are the Hawaiian Islands. Looks like it might actually pass north or over. So yeah, there's a good chance of Hawaii getting slammed by Flossie. And in fact, most of the models have it going right into Hawaii. So very bad news. Atlantic disturbance could intensify this weekend. So yeah, that's even worse news. That's what I was going to talk about. So Hawaii right now, I think Flossie is the main thing for Hawaii. I'm not so concerned about Eric for Hawaii, but Flossie I'm very concerned. Flossie is a major hurricane, but I'm not Flossie. Eric is a major hurricane. However, Eric will miss Hawaii, while Flossie is just basically making a beeline right towards Hawaii. And if it becomes a major hurricane, Hawaii, you're screwed, I have to say. I mean, this is not normal, but with global warming, the ocean's getting warmer. This is becoming the new norm, unfortunately. In fact, let's go to sea surface temperatures right now. So let me make sure everything's going fine. Oh, great. There's why. There we go. Fix that little error. I thought it was Erika. Yeah, some people were calling it Erika, so it kind of got, everyone's so used to female name storms that when it's actually male named, because Erika is sounds more common than Eric. Like, it's usually E-R-I-K, not E-R-I-C-K. So I just a little bit of a different spelling from what I'm used to. So Hurricane Eric right now is a Category 4 hurricane. It has a very concentric eye wall there. That convection has entirely surrounded the system. And that is Hurricane Flossie. It doesn't look like a hurricane because of how it's shaped, but center of circulation is right in there. And look what they said. Atlantic disturbance could intensify this weekend, and that's the one that just went off Cape Verde's. That's Eric, and that's Flossie right there. That almost doubled the 35 miles per hour in less than 24 hours needed to qualify as rapid intensification. So at 5 p.m. Monday, Eric's top sustained winds jumped from 70 miles per hour at 5 p.m. Eastern Daylight Time Monday to 130 miles per hour 5 p.m. Tuesday. A spectacular leap. So that's almost like, this is not only rapid intensification, this is hyper rapid intensification. In fact, there's Hurricane Patricia back in 2015 was even wilder. It went from a tropical storm to a Category 5 hurricane in only less than 24 hours. That's even more impressive. So now, Hurricane Eric, thankfully, is going to miss Hawaii. But then Flossie, this hurricane right here, is going to head right towards Hawaii. Read this. 1 degree Celsius above average for this time of year. Global warming is definitely occurring. And there's no disputing it, because look at this. The entire ocean, the whole oceanic basin is basically above normal. You're only getting a little bit of below normal. Like it used to be, this is how it used to be. Let's go back to 2002. Just let's pick any year, pick 2002. Pick around the same time. So you could see the ocean was generally cooler. And now, right now, and by the way, white is sea ice. So let's keep track of the dates. Look at all that sea ice over here. Look at all that cool water on both sides of the ocean. You have some warm, cool, warm, cold. So it's kind of, and this is above normal. So this is climatologically speaking. And then, some years were a little cooler. Let's look at 2011, for example, around the same time. It was pretty cool, but you had a really warm blob there. Then let's go back to 2010, around the same time again. So you see, had a very strong La Nina. And the Atlantic was very warm, but the thing is, keep in mind, you had a lot of open blue waters. You had a lot of cool waters in the Atlantic. Let's go back to 1996. Let's go way back. Let's go back to the 90s. Actually, let's go to 97, because that's when you had the massive El Nino. July 29th, which is here's the thing. Again, you had a lot of blue waters, and this is when the massive El Nino happened. But then let's go to 1999. Let's go to July 31st, around the same time. Got a lot of blue. A lot of blue. A little bit of orange and yellow. Yellow means above 0. 0 means average. This is how much above average in Celsius, below average in Celsius. And now let's go to today. Let's go to right now. Just want to show you again. Look at that. everything is yellow and orange. Yellow, 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 yellow. Everything. The whole ocean. Everything. A little blue patch there. Blue is almost gone. Like there's almost no more blue. You get a little bit here in the Southern Ocean. That's because of all the melting sea ice. I mean, let's look right now. Let's look at Arctic again. Right now, we're heading towards a record low for sea ice. It's looking really, really bad this year. I'm telling you right now, we will dip below this. This is the record low. This is the lowest ever recorded. Previously was 2007. Okay. Just want to show you. This may be the worst year ever recorded for sea ice. Unless something happens, unless something like this happens, unless it just jumps, unless it crosses this threshold before it hits bottom, this will be the worst year ever recorded for sea ice, and it looks like it's on track for that right now. Let's look at the slopes right now, the rate of descent, and the rate of descent for this. This is last year, and this is this year. Big decrease in sea ice. Let's look at in Antarctica right now. This looks horrible. At least in 2012, we were way above normal, so that kind of compensated a little bit for it. But right now, show all. This is where we are right now. There's only 2 years, 1985 and 1983, which were worse than this year right now for Antarctic sea ice. So this is really, really bad. So yeah, for those of you who think global warming is fake, look at that. And I'm using government sources too. And look what we have in administration right now. This is all satellite records. This isn't being manipulated at all. This is all real. So you can say it's not real, but unfortunately it is. And look at the whole Atlantic basin right now. It's all warm. So let's go back towards looking at this and looking at the tropical Atlantic waters. This is the remnants, or this is 95L right here. This is what is to be 91L, and there's pretty good spin with this. And there's quite a bit of thunderstorm development with this right now here. Look at that. And it's pretty far south of Cabo Verde right now. Those are the Cabo Verde Islands, or Cape Verde. Look at that. There's some thunderstorm development here. It still has quite a ways to go, but now definitely looks interesting. This disturbance failed to close off a low-level center in a hostile less than 10% of ensemble members. Thursday and Sunday. So yeah, it looks like it won't really do much. That's not the system I'm worried about at all. This is the system I'm worried about. It's not really more. So yeah, it looks like this system definitely has a chance of development. Look, I only have one viewer right now. But I'm definitely thinking that that storm will become something. It will be named Chantal. So yeah, if it is given a name, it'll be C. This system is way too weak to become anything. I mean, look at it. It's just disorganized. Look at all that shear it's fighting right now. It's 95L won't do anything. Trust me. I mean, even there, it probably won't do much. You might become maybe a little more healthier, but I don't think it'll become anything more than an invest, which is basically what it is right now. It might become a depression, just might, because the waters in the Bahamas are very warm right now, like in the upper 80s. So let's look at the, okay, the stream isn't working again. What happened was my internet went out, so that's what happened, because I have Wi-Fi, you know. I'm not connected to the internet wired, so it's wirelessly, so sometimes, you know, shit happens. Make sure it's working. Okay, I'm back now. So currently, let's go to the Storm Prediction Center outlook. For tomorrow, we have a marginal chance of severe weather. So I'm just going to get to that. Let's look at the NAM right now, NAM 3KM. We had some thunderstorms. Actually, we had a severe thunderstorm that went into Manhattan. It was a pulse thunderstorm. And also today, the waves were very, very harsh. There was very intense rip currents today along the beach. In fact, there was a drowning, I believe. Let me see in the local news, because there was fire trucks, there was helicopters all over the place, like NYPD helicopters. I think there was something about a drowning today, because I was there at the beach and the waters were very intense. Yep, that's the one. I was there, so. Yep, I was there. So. Yeah, so I was about 30 blocks from there. It was way to my south.
They went in the water when they wasn't supposed to, with no lifeguards in here.
probably being smashed against the rocks.
They went in the water when they wasn't supposed to, with no lifeguards in here.
Yeah, they weren't supposed to be in the water. Not here. Like, you see all those rocks? When I go in the water, I always go down around 90th, 94th Street, away from the rocks. Because when you go by the rocks, you could get smashed into a rock or something. Even I myself, I was smashed into the sand. There was some big waves today. Surprised there's no high surf advisors or rip current advisories. In fact, because the surf was really, really rough today. Like, I'm gonna attest to it. The surf was incredibly rough. Really, really rough. In fact, let's see if they issued anything for the surf or for the waters. They issued any surf advisory or rip current advisory, because it would appear on the weather chart. Let's see. And we'll be getting to severe weather for tomorrow, because there will be a chance of severe weather tomorrow. Look at that. Be a chance of some pretty intense storms. So I'm planning on going to the beach tomorrow from about this time until about 16Z or 18Z. So, and that's when the storms are expected to fire up. Maybe there'll just be some strong winds. See. Nothing. They haven't issued anything for the surf, even for tomorrow. And yet there's going to be more strong winds tomorrow, especially before that storm comes through. My internet's really slow, so it's still loading. I have a really crappy internet connection. See, it's only at 1,066 kilobytes per second. It's really bad. Now it's okay. Now it's going to 3,000. Then it drops right back to 1,000. I mean, look at it. It's just, my internet sucks. Let's see how it's going through. And it's still not even full screen. There we go. And that should probably solve the problem now. Let's see, has it finished loading? Yep, it has. Ooh, it looks like there might be some hail, some small hailers. There's a chance of some hail. Some of those pulse thunderstorms might produce some small hail because they're indicating some high DBZ rates for, values for tomorrow. So might be a chance of some small hail. Some of the stronger cells. Looks like bigger threats for storms will be north and west of the city, because that's where the sea breeze usually takes place. Highs tomorrow will be in the upper 80s to low 90s. Still, nah, I think now I fixed it pretty well. sure it's on desktop. Yeah, I got it on desktop capture. Maybe it's supposed to be Windows capture. Let's see. Maybe that's gonna change it. Now it's gonna be the whole desktop. Or the whole window. So maybe that's gonna change it now, I hope. Let's go back here. Let's look at tomorrow's high. And right before the storms come in, this is some low 90s, and then boom, the storms are going to come right in. What's that wind gust for tomorrow? So it's going to be pretty breezy along the coast tomorrow. Sure. Oh, there we go. Okay, finally I fixed it now. Let's look at the weather for the next several days in the Northeast. Let's look at the surface temperatures now. And I wanted to show you something very interesting. This is what I intended to show you. Let's look at buoy 44014. Actually, no, that's not the one I really want to show you. The one I really want to show you this is a buoy that's few details. So this is a buoy that is off the coast, like pretty far off the coast. This is even further off the coast. The water temperature is still in the mid to upper 70s. Let's look at this buoy. Should be around 79 degrees. At 81. Yeah, water temperature 81 degrees in New York Harbor. Like, that is just incredible. Let's look at Robbins Reef in New York Harbor. Of course, they don't give water temperatures, but they should. Of course, I don't hear. Battery. That can't be. Oh yeah, that's from It's because Hudson River waters. Great South Bay water temperature. Yep, look at that. 83 degrees, almost 83. Great South Bay. Oh, that's very nice. Look at those water temperatures in the 80s. Yikes. That's incredibly warm. Let's look at Long Island Sound, which is a pretty big body of water, actually. This is looking at Bridgeport now. They even give water temperatures, but so it's in the 70s, so not as warm. Looks like the smaller bodies of water. This is way off Montauk Point. And they don't give water temperatures. So this is 44066, so that's Hudson Canyon right there. And that canyon's there because of the, it's basically a river in an ocean. Because, the Hudson River flows from New York. That's because of the Hudson River. That's the flow from the Hudson River, actually. Wow, that's incredibly warm. Jeez! My God. Look at how warm these waters are. I've never seen it this warm before here. That's unheard of. My God. That's bad. That's really bad. And that definitely looks conducive for tropical development, I have to say. Looks like I just gotta move it just a little bit. Just a little bit. Perfect. Got it. Alrighty. Because I'm gonna get the whole page up there too. Perfect. All right, so let's go back to looking at air temperatures again. So upper 80s, so maybe around 90 tomorrow. Thursday, 85, so be very warm. And let's see how this is going to impact our water temperatures. Very warm. Very warm. Very warm. And look at that. 80s off of Delmarva. 80s, 80s, 80s for highs, 80s for high, 80s for high. I mean, look at that. Incredible. It's incredibly warm. This whole water, like, this is when having onshore winds is just like really. Let's see. Of course, I think it's gonna get cooler. And there's that storm right there. That will be future Chantal, or maybe Dean, if it gets the D name. It looks like it's going to go off the coast and be no real threat to us. And that's according to that model run. Let's look at the current runs. Oh, wow. There it is. That's going to be Chantal. And then boom. So I said around August 4th or 5th it will become something, and then pass right over Puerto Rico, and then basically you'll have this system right here that's going to kick it out. Yeah, this system is not going to be any threat to the coast. Looks like it's going to go out to sea. I mean, this is looking all the way towards August 11th. Looks like it won't really be a threat. This is looking on July 28th. That time they didn't expect the system to do anything. In fact, it's almost as if it didn't exist. And this was this morning, in fact. Nothing more than an open tropical wave. There it is right there. Very close to the coast, mind you. That system here. Let's track it. And then this is the midday run of the GFS. There it is. Tropical wave. Nothing more than a tropical wave. And then look at that. Maybe a depression at that time. Looks a little interesting. Oh, now it's doing something. Now it's maybe a strong tropical storm, hurricane. And that is a close call. And that storm takes a little bit longer to get here. Just a little bit longer. Goes right up the coast. And then you get a big storm. Let's look at hour 273. Okay. Let's go to 18Z. What kicks that storm out? Why does it go out to sea? Let's see. So, looks like you had a cold front here, which broke down the high pressure system. You have the low pressure system coming out here. This is August 6th to 7th. That same system just comes through willy-nilly, doesn't do much. Just, you know, basically a really weak cold front comes through, doesn't do much. And then on its heels you get a very strong reinforcing shot of cool air coming through. But that's on August 11th. Here you have a pretty strong system coming through. and then that kicks the storm out. So there's a cold front draped with that. And then where does it go north? We have that cold front draped across the East Coast and going into the Western Atlantic, and that kind of causes a weakness in the high pressure system, allows the storm to go off the coast. And let's look at the European. Now this is when we have to start taking a look at the models. Let's look at tropical Atlantic or North Atlantic, and that's a system. It's right about here actually, so that's, I don't know why it's showing 1013 over there, but there it goes. That's a system. Right now it's about here, so that looks pretty accurate. There we go, 1011. It's definitely kicking the storm up. And yeah, even the European has it going out the coast, going out to sea. So even the Euro, you know, this storm is basically no threat to us. And what does the midnight run of the other night say? Ah. Ooh, yeah, that could be a problem, but no, it looks like it's still gonna go out to sea. Because you see that cold front right there? See the 1012 there, kind of draped like that. So it goes over Hispaniola into the Bahamas, and then right into so kind of like that on northwest, and then it's just gonna basically do, yeah, like that. So yeah, it's basically gonna go out to sea. Especially if it develops sooner rather than later, the stronger it's gonna be, the more the steering currents will be able to pick it up and take it out to sea. The bigger concern is, what if it goes a little further south, gets stronger, and then enters the Gulf? That's going to be a really bad case scenario. Let's go to spaghetti models right now. Actually, oops, I already have that open. So let's go to spaghetti models. They're already giving you a 40% chance of development. So basically, I was thinking it was going to do the same thing. Something like that, and just go out to sea. Or more realistically, something like that. It's going to basically curve out to sea. It's usually storms in late August and early September that just kind of parallel the coast. They go really far south and then do that. As I'm looking at the model right now, I'm going to look at the Canadian right now, see what it's forecasting, but there it goes. There's that system. That doesn't make any sense. Let's go to NavGem then. NavGem is usually much more realistic. NavGem has a pretty strong already early. NavGem really has it interesting. Look at that. It's already a tropical depression, tropical storm. Look at borderline tropical depression, tropical storm. Look at that. And if it does that, it very well may actually become a hurricane. And it could very well then threaten the East Coast. So that's a Navy model. Let's look at Icon now. So let's look again at the tropics. So good evening, and thank you for joining me. There's 95L or 95L and 91L. This will become Chantal, and this, I think this system might become, basically if this system becomes this tropical storm, then it will be Chantal, and this will be Dean. Actually, no, not Dean. Let's see, 2019. I forgot we already had Dean, so I think it will be Dorian, yeah. I forgot Dean was retired in 2007, which actually happened to be 12 years ago, so yeah. I think I became a Category 5, so they had to retire it. Yeah, it was also a really strong Category 5 too, with 905 millibars, and it happened to form on August 13th. It was an August storm. Look at that. My God. It was a crazy system. And it made landfall in the Yucatan as a Category 5. Like, it was crazy. Funny thing is, you didn't have that many hurricanes. You only got 2 O names. It only dropped down to 929, which is not even as strong as. But it made landfall as a Category 5 as well, right in Nicaragua. And right now, I'm trying to find where that tropical Atlantic satellite is. I think it's Spaghetti Models. I had that satellite. There we go. That's what I was looking at. This is looking at Geo 16 right now. So that's what will become, you know, so it's basically, it's a battle between who gets named first, or depression first. Is it going to be this system, or is it going to be this system? So it's basically a battle between the 2 storms right now. It's still loading. Come on. That's a pretty good blow up of convection right there. Wow, that's really good. It's a really healthy blow up of convection. And the strongest shear is still to the north. Trying to find, there we go. So there's a favorable, unfavorable map. So look at that. All red is highly favorable. So you have an entirely very favorable for development. Let's just look at that right now. So highly favorable for development. So this is the one area that, It has to fight this highly unfavorable area of development because right now it's over here. I mean, if it was here, oh man, it's gonna blow itself right up. But let's see if this map is accurate. Let's look at Geo 16. Definitely, there's not much shear over here. No, there's some shear over here. Shear's moving mostly south to north, so same direction as a storm. Yeah, there's some very strong shear over here right now. So once that shear weakens, it could really get its act together. And you have this system to worry about as well. But from the looks of it, this area of highly unfavorable development is really, really small. So it's really sharp between highly favorable and highly unfavorable. Very, like sharp, cut off. It goes right from highly unfavorable to favorable. It's just, as long as you stay in very favorable, that's where you want to be. It's unfavorable here because of cooler water temperatures. Here's unfavorable because of wind shear. But here it's because of water temperatures. That's why it's tropical intensity index. Look at that. Pretty good blow up of convection. I don't know if it's gonna do anything, but tropical wave right now is right over Hispaniola, so looks like convection is trying to form around it. It looks like it is trying to get its act together. This is what you want to look at right now. You want to look right at the Caribbean. And it looks like it's still fighting shear. And why is it fighting that shear? You want to know? Oh, great. I hate when that thing pops up. You see that little swirl right there? Almost, you could barely make it out. Not that one over there. Not that upper level low, but fact. Let me go to weather that cod right now. There's a bit of an upper level low. Where's that swirl I saw? And it looks to be well northeast of Puerto Rico. There it is. tropical Atlantic Ocean. So this is basically water vapor looking at the air mass. Is it dry or wet? There's quite a bit of dry air over here. So there's a swirl right there. It's basically an upper level low in the central Atlantic. I mean, in rare cases, these mid to upper level lows can translate down to the surface and become a hurricane or tropical system, but that's very, very rare. Not a lot of dry air. I mean, there's a lot of dry air to the north because of the Saharan air layer, but not a lot for the system to endure, so that's good news for the system. Looks like another wave is developing off the coast. The models usually start hinting on it once it comes off the coast, but sometimes the wave is so powerful that the models hint on the wave even when it's on land. But it's still early in the hurricane season, so a lot can still happen. So this will become a hurricane, I would say, in maybe a week or so. So right now, looking at the Atlantic again. Looks pretty interesting. This is a new development right now. There it is. This is Invest 95L right now. Or, yeah, this is 95L. So there's a blow up of convection right almost on top of Invest 95L. This is where it was at the 11 p.m. advisory. Now it should be about here. So there's pretty much a blow up of convection right on top of the tropical wave. And if thunderstorms can continue to circulate right on the tropical wave, a hurricane could actually potentially or tropical system can form. But as you see, it's fighting a lot of shear. I mean, look at all the shear it's fighting. I mean, if this system was over here, different story. But it's been fighting this little low pressure system the whole time. And it's basically this one big low, and it's an upper level system, so there's a lot of upper level shear to deal with. See right here, you can see the swirl right over here. You almost make it out. You could almost make out that swirl. See, there's some really fast winds here. You just keep in mind this is only an hour and a half of motion. And look how fast these winds are just screaming. Let's go back to spaghetti models. I just want to show you where that system is located. Oh. That's an outdated chart. That's a really outdated chart for water temperatures, because here they're showing water temperatures in the 40s. Look at that dark blue. Water temperatures of New York City are like in the upper 70s right now. Should be like here, like. In fact, you want to see water temperatures near New York City right now? Prepare to be amazed. Like, for all of you who are watching right now, so for that one person who's still watching me, I'll show you one really cool thing. Alright, so I'm gonna go right now to NDBC, National Data Buoy Center. So right now we're in nationaldatabuoycenter.gov, ndbc.noaa.gov. Okay, let's zoom all the way in to the closest possible buoy, which is right to the furthest possible buoy, which is this one right here. This is one that's off the coast of New Jersey, like pretty far off the coast. Usually water temperatures here in the low to mid 70s. The warmest it usually gets. Water temperature here, 77.2. Abnormally warm. Oh, that's not all. I've never seen it that warm there. Usually it's actually in the low 70s there, like 72, 73. That's the warmest I've seen it there is maybe 75. And today, it's 78. Oh, that's not all, folks. That's not all. You want to see something more? How about Sandy Hook? Water temperature, 81 degrees. Oh, that's not crazy enough? Ho-ho, it's gonna get crazier. Let's go back here. 83.3 degrees. Right in smack dab in the middle of the afternoon. Same time yesterday. 80 degrees. Whole degree warmer right now. Air temperature 79 degrees. Air temperature 78.8, water temperature is 81. And let's go to this one right here. Usually the warmest I've ever seen it there ever is around like 75, 76. Like before this year. So this is approaching record territory. Like, I've never seen it that warm there. The warmest I've ever seen it here is around 73. Like, and that was already, oh my god, I think one time I've ever seen it hit 75 there. One time. That was last year, I think. I think it was 70. I don't even know. The warmest I've ever seen out here is maybe 70, 69, 70 degrees. It's the warmest I've ever seen it out here. Yeah, see? Yes, it was 71 there, so. The warmest I've seen out here, but here it's further south. So I've seen it get up to 75 there, so. The warmest I've seen it here is around 70 degrees, 75, I think. So let's look at that. So let's go back to sea surface temperatures. This is from July 29th. Look at that red right there. You see that? See how deep red it is? Because that's how much above normal the water temperatures are there. Can you see that? It's orangey color. It's because it's 2 degrees Celsius above normal off the coast of New York. The Northern Gulf is still pretty cool. Could be upwelling from Michael, possibly. Or I think it was not from Michael, from Barry. That's Barry's upwelling. There. See, around July 15th, that's just right around when Barry formed. So Hurricane Barry, July 11th to July 15th. And it organizes tropical storm on July 11th. Yep, so that's July 11th. Tropical storm at this point, boom, upwelling. Yeah, Barry did a really good thing by doing some of that upwelling. Took some of the energy away, but then look, the whole Gulf warmed up again. But then, I guess all the waters from the Mississippi River just flooded in and cooled it all down. So while the waters became warm again from Barry, like after Barry's pass, everything got warm again, and had all that water that just flooded right back down. Look at that July 22nd. Look at that almost orange color. Yep. I think it's going to be filling up like that again. I mean, look at that. Look how warm it was here. It's incredible. Now this year, having a lot of warm here. I mean, look at all that. This is a sign that this winter might be very warm. I mean, cold, actually. Sorry. Like July 30th. How warm it was here, like up to 2 to 2.5 degrees Celsius above normal. And right now, it's up to 3 to 3.5, so very warm here. The whole Eastern Pacific is just, the whole Northeast Pacific is just warm. If you have that warm blob there, that's gonna be very, very conducive for big storms. Warm here, and cool here. I mean, this is just amazing for snow. Why? Because you'll have a really good high pressure system here. So basically, you have the sliver of cool here, which prevents El Nino from being too strong. You have some warm here, which cause some tropical moisture to be fed in. So you'll have a very strong blocking high over Greenland. I mean, because of that here. You'll have a strong blocking high over eastern Alaska and the west coast. Then you'll have a trough that digs into the eastern part of the country, and you'll have storms riding on the eastern part of the trough that go up the coast. And you'll have a blocking high here, so it'll be something like this. Or on a more extreme version, something like that. If you want to get really extreme, it might even be like that. And then when you have a storm, you'll have a storm that basically goes like this. Or you'll also have an Arctic front and then, or something like that. And if there's a blocking high, you might have a storm that goes like this. And then boom, just dumps tons of snow on the coast as it hits the Gulf Stream and then goes out to sea. Because you'll have a very cold land, very warm waters here, and just blow itself up. So right now, right in the main development area, very warm waters. But look what's happening to the south. And right around here. See that here? Let's look around here, right there. Let's see that difference. If that cool water will spread, what you're seeing here is that current, that cold current. You know, the thermal line circulation belt. Goes like this. This just circulates around the whole world. And what is this, you ask me? That's the Gulf Stream being disrupted. That's the disruption of the Gulf Stream. And why is it so warm over here, even though the Gulf Stream is being disrupted? That's because of the positive AMO, the Atlantic Multi-Decadal Oscillation, the AMO. But the Gulf Stream is being weakened. I mean, this is where the Gulf Stream passes through. And look at that. Up to 3 to 4 degrees Celsius below normal. So the Gulf Stream is being disrupted. Because there's too much fresh water. And eventually you'll have the whole Northeast Atlantic just being really cool. Well, it'll be warmer than normal here. Well, I'm expecting 18 to 20 named storms, 10 to 12 hurricanes, and 6 to 8 major hurricanes. That's what I'm anticipating for this year. Actually, let me refine that. So 18 to 20 named storms, 10 to 12 hurricanes, and 6 to 8 major. That's what I'm anticipating for this year. Because we already had a hurricane, and that was Barry. So, why am I anticipating so many storms? Well, for the most part, you have a La Nina. We have warm waters here. Actually, no, 18 to 20 is too much. Actually, I'm going to refine that again. It's going to be actually 16 to 18, not 18 to 20. I want to do it in odd numbers. I mean, even numbers. So I'm expecting 16 to 18 named storms, 8 to 10 hurricanes, and 6 to 8 major. That's what I'm anticipating this year. So I refined that for 16 to 18 named storms. Let's see what the National Hurricane Center said. Near normal. Near normal? And they're giving such a big range of 9 to 15 named storms? Oh no. This is not going to be a near normal year. I'm sorry to say. It won't be near normal. We're going to have an above normal season. Yeah, we're going to have an above normal season. Why will we have an above normal season? Well, all that warm water here. The fact there's cooling going on here in the equatorial regions, there's a La Nina trying to form. There's a La Nina there are La Nina conditions that are trying to form right now. El Nino has been wiped out. Like, this is no longer an El Nino. If you're looking at the, like, you have some warm waters here, but look at that. You're having a La Nina. This is quickly developing into a La Nina, like really quickly. Early July, you're having La Nada conditions. Right now, we're having La Nina conditions. So yeah, we're having a forming La Nina right now. It's still neutral, but we are heading towards a La Nina. Let's go to ENSO plumes right now, from the University of Columbia. Yeah, let's go to Columbia University and look at their ENSO plumes right now. And that really quickly dropped. Like, this is just, it looks like it followed this trend. Looks like it really is following the La Nina trend. It looks like these models might have won out, because we're in fact heading for a La Nina right now. And just earlier, this was saying we might have a moderate La Nina, moderate El Nino, but it looks like this may no longer happen. It looks like we may end up being towards neutral, and then we might have a La Nina developing towards 2020. It looks like a La Nina will develop. Yep. Jesse Philbrand is really going to be happy to hear this. And it looks like what he wished for is happening. We're having a La Nina right now. Warm waters here, warm waters here. Means Wisconsin's going to get a lot of cold and a lot of snow. I don't know so much about snow, but a lot of cold. Because for Wisconsin, their setup's slightly different. Looks like they'll get a lot of those Clipper type storms, you know. It's quick shot snow. And it looks like most of the snowstorms will tend to be, it'll be more of a zonal flow, but you'll have a northwest flow. So yeah, Wisconsin will see quite a bit of snow this year, I have to say. So will the Northeast. With the yet with the Pacific, the eastern, the Western Pacific, the Western continent, like the West Coast. It's hard to say, but because of all this warm here, because of the Northern Pacific being so warm, you'll definitely have a Pineapple Express. Even though that's common during El Nino years, you will definitely have a Pineapple Express. You'll have a Kona Low, you'll have a Pineapple Express. So you might have a ridge, but you will have Pineapple Express storms, which could give quite a bit of rain to California. Only reason I'm forecasting a Pineapple Express is because the Pacific is so warm as a whole right now. So if we go back to 2014, 2015, when California was having their big drought, what did the Pacific look like at that time? There was quite a bit different. See that very cold, I don't think that's accurate. I think that's some glitching going on. But yeah, it was cooler. It was more broken up. And of course, it wasn't dark. It wasn't that color, I think. It looks like it had some really cold waters. -5, that's crazy. I don't know how that came about, but hmm. 2013. I think it has to do with a hurricane. It looks like that's some crazy upwelling there. Anything from around that time? Looks like there's nothing that should have caused all that upwelling. Oh. Just before Patricia formed, the Atlantic had the most intense storm ever recorded in the Western Hemisphere. And then Patricia stole it. And it like Hurricane Patricia set multiple records for maximum strength, rate of intensification, and rate of weakening throughout its relatively short existence. It's incredible. So, yeah, I mean, this is incredible. It just blew up. Like, it just blew up. And it was October. It was October 20th to 24th. Second lowest air pressure ever recorded globally. Wow. It was a very small system too, like really small. Even though only 8 people died. Yeah. Alrighty, so let's look at this again. Let's look at Geo 16. Can you reset it again? Let's look at an emanation loop again. Looks like convection is starting to fall apart. There's still some convection, so it's very weak convection though. There's that system right there. Looks like the swirl's around there. The tropical wave is there. Could be another wave coming off of Africa right there. There's still a good amount of shear over here. That's a system to watch. This is looking at the European right now. Let's look at the Canadian right now. So that's 91L, and 95L will be right about here. let's go back to water temperatures again. I just want to show you that. This is back in 2013. Let's go to 2015. Let's see if Patricia had any effect on the sea surface temperatures. This is right roughly where Patricia formed. And after Patricia dissipated, no effect. None. And that's not where Patricia was, by the way. That's just some other upwelling. But no, like Patricia barely had a dent in anything. Because this El Nino was so strong, Patricia didn't even have an effect on upwelling waters. That might be the only effect right there. Barely a dent. Ask me. Thank you for watching. Have a great day.